This is the Digital Cure for Epilepsy project, and basically we're designing a neurostimulator in an effort to depress seizures that are happening in real patients with epilepsy. This project was sort of born out of the vertically integrated projects, which came out of Georgia Tech. It's a teaching method where upperclassmen work with lowerclassmen, and we use graduate students as mentors in order to complete our goals for the project. This year we came in with an algorithm that was very good at predicting seizures that we created. Basically transferred it to hardware, real hardware that can run real patient data in real time.
As a broad overview, what our system is trying to do is predict and prevent seizures in real time. So the first stage of our system is to record neural activity from the brain. So we have these little devices called intracranial electrodes that can record electrical activity that's going on in the brain. So that activity is then sent to this piece of hardware that we designed. This piece of hardware has an algorithm on it that we also created that can take neural activity and produce a seizure prediction. So using the electrical signals that are occurring in the brain, it can predict whether or not a seizure is likely to occur in the next 5 minutes or so. So this piece of hardware that we designed then communicates back to the brain if a seizure is about to occur, so that in the brain we can apply electrical stimulation or neurostimulation, which can actually prevent the seizure before it occurs.
So the future of the device comes in two major parts. So you can see here, there's our board. And so the board looks really big, and that's going to become a chip that's implanted on the skull. And so for size reference, it would be about this size. So you can imagine it would be this chip plus a battery, and that way you could replace the battery whenever you needed without having to do any kind of surgery. And then the other part is the electrodes. This may look like an empty box. There's actually tiny little electrodes in here, and they've been created by Rice. And so they would replace this, and they would basically be implanted on the brain, and they would communicate wirelessly with the chip that would be sitting on the skull. And so that would be our whole communication system, as they would just be communicating back and forth wirelessly.